Okay, so again, topic 3, day 1, sets, intersections, and unions. So we're going to start with Roman numeral 1, set vocabulary. And a lot of what we're doing today is vocabulary. Okay, so the very first word is set. And a math set is a lot like what you would think of just with English. A set is just a collection of numbers. That's a set. So when you label a set, you use a capital letter as part of the label. So, for example, if you wanted to say set B, you would use a capital B, or set Z, capital Z. So that's how you name a set. Okay, number 2, elements. Elements. The elements are the members of a set. The members of a set. Okay, so how do you actually say a number is a member of a set? You might say the number 9 is an element of set B. And that's how you use it in a sentence. 9 is an element of set B. If you want to say 9 is not an element, that's how you say it. You just say 9 is not, and then the rest is the same, an element of set B. Now, naturally, we know that there's got to be a shorter way to write this because math people, we're lazy. We never write anything out if we can help it. So here is your notation way of saying the same thing. If you want to say 9 is an element of B, the element symbol is a short, elongated C with a bar through it. It kind of looks like a short pitchfork. That is 9 is an element of set B. And that is an epsilon. That's the Greek symbol epsilon. And to say 9 is not an element of set B, it's probably what you could guess. 9, and then you use your epsilon, except that you put a slanted line through it. It has to go at that angle, not up and down or left to right. Okay, so that's a little bit of element notation. Okay, number 3, roster notation. Roster notation. Okay, roster notation is a way to show a set. And just like a team roster shows all the names of the team members, roster notation lists all members of a set. So it really is a roster of set members or elements. So for example, let's say that you want to make the set all whole numbers greater than 20. All whole numbers greater than 20. So that's a description of a set. And we're going to call it set Z. And in roster notation, you have to start the set with what's called a brace. A brace has a bump, a nose, and a bump. I think of it as like a forehead, nose, and chin. That's a brace. And then these are all the whole numbers greater than 20. So greater than 20 means not actually equal to 20. So 21, 22, 23. Now this set keeps going. So if a set keeps going, give enough elements that you can tell what the pattern is. And then you finish with a comma, a dot, dot, dot after the comma, and then another brace, but going the opposite direction. In English class, ... means etc. In math class, ... this means the pattern continues. Means it goes on infinitely. So that's how you do roster notation. You list the members. If you need to do a ... the pattern continues, you are allowed to do that. All right, number 4. This is the other type of notation that we need to learn. It's called set builder notation. Set builder is hyphenated. Set builder notation gives a description. It gives a description of how the set is built. It gives a description of how the set is built. Keyword is it's a description. It's not an actual list of the elements like roster notation. Instead, it describes it. So let's say that we're going to do the same exact example. So we're just going to do the same one. All whole numbers greater than 20. So the notation starts the same. Set capital Z equals, and then a brace. And then you have a lowercase x and a bar. So far, what have we written? The way you read this, set Z, the equal sign is. The brace is the set of. The first letter after the brace is all x values. And the bar is best interpreted such that. So far we've written set Z is the set of all x values such that. Okay, so the first thing you do is the type of number. In this case, x is a whole number. So that whole part is a complete sentence that gives you the type of number. And here's the limits. X is greater than 20, close with the brace. So the second part is an inequality. It's the limits on X. What is it greater than? What is it less than? It's basically the domain of X. So the number type goes first, and then the description of what its limits are. All right, let's do another example. Okay, we're going to do the set B of odd numbers less than 7. Odd numbers less than 7. All right, in roster notation, you start out with set capital B equals, and then a brace. And it didn't say positive odd numbers, it just said odd numbers less than 7. So we're actually passing into the odds the negative odd numbers as well as the even odd numbers. So we start with 5, that's less than 7. Then we go 3, then we go 1. 0 is not considered an odd number or an even number. 0 is just 0. So we're going to skip that. -1, -3. And by then, the person who's looking at this is going to know, hey, these are odd numbers, both positive and negative. So you end with a comma, ... The pattern continues, finish with a brace. All right, we're going to describe the same set using set builder notation, which starts the same. Set B equals, and then a brace. Now in Set Builder, you put an X, then a such that bar, such that, and then you start with the description. X is an odd number, so that's what goes first. X is an odd number. And here's where we put the limits on it. X is less than 7, so we just say and X less than 7, and in a brace. Okay, so on your homework problems, you've got to know the difference between a whole number and an integer. So just a quick review. A whole number is all numbers that are positive plus 0. So that would be 0, 1, 2, 3, and then it would go up from there. The other word you're going to see a lot of is an integer. An integer is negative and positive plus 0. So if they want an integer, it goes infinitely low, and then -2, -1, 0, 1, 2, and then it goes infinitely high. But an integer represents both negative whole numbers, positive whole numbers, and the number 0. All right, so that is your 2 types of set notation. By the way, which type did I just use here? Did I use Set Builder or did I use Roster? Which one is that? Roster. Yeah, I used Roster because it's a small set. If it's a small set, you can use Roster, no problem. If it's a gigantic set, then you're probably going to want to go to Set Builder and more describe it than actually list it. Okay, so we're going to go to Roman numeral 2. Intersection vocabulary. Intersection vocabulary. Intersections are how sets of numbers interact with each other, how you combine sets or overlap sets. Those are all intersections. So let's start with number 1. What is an intersection? Okay, an intersection is the set of all numbers common to both sets. So it's only what they have in common. That's an intersection. So if I wanted to show an intersection, let's say that I have set A, which is a big set of numbers, and I have set B, which is a big set of numbers. The intersection of set A and set B are the numbers that they have in common. So it would be the numbers here where the 2 sets overlap. That's an intersection. And you write it capital A, and an intersection looks like an upside down U, but without the stem. And the way you say it is you say A intersection B is, and then you would talk about what it is, but that's how you say it, is A intersection B. Okay, so let's do an example of this. Let's say that set A is the set of numbers 1 through 6. 1, 2, 3, 4, 5, 6. Set B is the set of numbers -2, -1, 0, 1, 2, 3. So starting at -2, going up to 3. All right, your mission is to find A intersection B. So on your paper, you would write A intersection B equals, and this is definitely roster notation. And you would list any numbers that they have in common. Well, the only numbers they have in common are 1, 2, and 3. So that would be your intersection set. All right, let's say that they don't have anything in common. They have nothing in common. Then their intersection would be called the empty set. It's also sometimes called the null set because it has no numbers. So if they don't have anything in common between set A and set B, you would write A intersection B equals, and then you would just write empty braces. That would be your empty set. Another way I've seen it written is A intersection B equals, and then the null symbol is a little circle. It's not an O, it's not a 0, it's a circle with a slash through it. And that's called a null symbol. You're like, wait a second, you mean Ghostbusters didn't invent that? Nope. 3,000-year-old Greek letter. So it's been around a while. The one thing you can't do is combine this and this. So you can't have braces with a null inside it. It has to be one or the other. Okay, so an intersection is the set of all numbers they have in common. Number 3, then the second type of interaction is a union. And the union is the set of all numbers in both sets. And when you put this one together, you list the numbers only once. You don't list them twice. Okay, so drawing our little drawing here again. Let's say you've got set A, which is a bunch of numbers, and you have set B, which is a bunch of numbers. In an intersection, it's just what they have in common. In a union, it's everything in A and everything in B. So it's everything in both sets, not just what they have in common. The symbol for this is A, and the union symbol looks a lot like a super tall U, but no stem on it. That's A union B. And again, just don't make it like a U with a stem on it. It's a Greek symbol, it's not the letter U. All right, so using A and B from up top, we're going to now do A union B. So you start by writing A union B equals, and then a brace, and then you have to list everything that's in both of them. Well, there's a -2, a -1, a 0, a 1, 2, 3, and then there's a 4, 5, 6. And those are all the numbers in both of them put together. That's a union symbol. Okay, so that's as far as we're going to go today is intersections, unions, roster notation, and set builder notation. You have to be really picky about notation. Just like you start a sentence with a capital letter and you end with a period, you really can't leave those out. They have to be in an English sentence. Same thing with the details on this. All the little marks and symbols have to be there. So you got to be really, really detail oriented when you're working on it.